Alright, so to begin with, I just wanted to go through a brief overview of what happens with specific immunity one more time. Remember that the lymphocytes, the Bs and the T cells are all very specific, and they are only sensitive to one type of antigen. So what happens in specific immunity is you have the antigen first coming into the body. Typically when the antigen enters into the body, it's going to be engulfed by a macrophage through phagocytosis. Upon being digested by the macrophage, some of the components of whatever's being eaten, let's say it's a bacteria or a virus, they'll be presented by the macrophage to the outside world. So basically what's happening is the macrophage is showing a number of different antigens on its cell surface. That's where helper T cell comes into play here. Now remember, helper T cells are very highly specific, just like cytotoxic T cells and B cells. And if they come into contact with a macrophage who happens to be presenting, a protein that they're sensitive to, they'll become activated. And remember that the first step when a lymphocyte becomes activated is always clonal selection. So it goes through division to create hundreds or thousands of copies to be able to defend against the foreign invader more effectively. After it's went through the process of clonal selection and created multiple copies, then what you're going to have is helper T cells traveling around through the body and trying to activate either B cells or cytotoxic T cells, killer T cells. Now, whatever the helper T cell was activated by, that antigen, it is only going to be able to stimulate or activate cytotoxic T cells or B cells that are also sensitive to the exact same antigen. So you can't have, for example, a helper T cell which has been activated by the tetanus toxin going around and helping out your B and T cells, which might be sensitive to a protein in Salmonella. Okay, so it's very highly specific, and the helper T cell can only help out, its colleagues, its B cells, and its killer T cells that are directly sensitive to that same compound. When a helper T cell encounters a cytotoxic T cell, the first thing that it's going to do after activating that cytotoxic T cell is that the cytotoxic T cell will then go through clonal selection as well, creating hundreds or thousands of copies of itself to better defend the body against the foreign invader. Remember that cytotoxic T cells, or killer T cells, they search the cells of the body for antigens that are within the cell. So for example, if a virus had taken over a cell and converted it into a viral factory, it would be searching for viral proteins being presented by those cells. If a helper T cell were to activate a B cell, the first thing that a B cell would do is also go through clonal selection, creating many copies of itself to better defend against the foreign invader. Once it had been activated and become an effector cell, it will then start the production of antibodies, and you'll remember that in the last class we talked about a number of ways that these proteins can work in defending the body against foreign antigens. So in each of these cases, once a cell becomes activated, it goes through clonal selection and produces many copies, and as part of that, some of those cells that are created become memory cells. So the effector cells might only last a short period of time, but the memory cells can last decades, and they can provide lasting immunity in the case of second exposure. So if an antigen were to be entering into the body a second time, the response would be much faster and much more vigorous as a result of the memory cells. Remember that in the beginning you might only have one B cell that's sensitive to a single antigen. So what's the chance that that one immune system cell will come into contact with that antigen? It's going to take some time. It's going to take a while. But if you have dozens or hundreds of memory cells left behind after an infection, then the chance or probability that they'll come in contact with that antigen will be much higher, and so it'll happen much more quickly and the response will be much more effective. This is what gives the name to the immune system. Once you have caught a disease once, you can't catch it again.